Okay, hi and welcome to Notes 3.6 Part 2, where we talk about solving absolute value. Oops, there's the value part. But this time it's going to be done with inequalities. Now with the equalities or the equations that we just did in part 1, we got two solutions, right? Where the v intersected the x-axis and we got two locations. But we know with inequalities that there's shading involved. So there's going to be many solutions with these. And with that, what we actually get with these inequalities is something we're kind of familiar with, which is an compound inequality, shall I say. Let me check that off. It's a compound inequality. An and compound inequality where we get an overlap of the solutions, or we get the opposite. That's not the best word for it, but that's what we've used to describe it, where the solutions don't overlap and they're exactly opposite of each other. There should be no intersecting portions. And you're like, well, wait a minute. So we get compound inequalities when we solve an absolute value inequality? Yeah, we do. It's kind of crazy. So we're going to mix those two things together, and we should be pretty good with ors and compound inequalities. So all we're going to do is tag it in with an absolute value part, and it's really nothing that you haven't done in part 1. So this is great. We're going to take part 1 and mix it with something that we already know, and we should have what we're doing. So let's get down to it. There is something that you might want to memorize. If you're doing these and you have a less than sign, you can see in this example that I've got on the left that there's a less than sign. You might want to memorize less than. And the reason that you might want to do that is if it's a less than and an absolute value inequality, you're going to get an and, hence the and's highlighted here, compound inequality out of it. So you're going to get an overlapped solution. All this means is that when you see an absolute value and a less than sign, you know your solutions are going to overlap. That's it. It's just helpful. And if you get a greater, see the play on words, or, then you're going to get a or compound inequality where the solutions go away from each other. Okay, so that's just a helpful clue to let you know what your solution is going to look like when you're done. The process is the same. Nothing changes. Here's your process. You're going to do what we know to do for absolute value inequalities, which is 1, isolate the absolute value. You'll see that that's isolated on the left, and I won't do both at the same time, but we might as well talk about it. This one's isolated on the right. You'll notice that those are the exact same thing. The only difference is that there's a less than sign on the left and a greater sign on the right. So you'll see what happens with the solutions. You can already see visually. I left the solution up for you. So they overlap when it's a less than, and then they go away from each other from the exact same boundary points, right? -4 and 5, and both these go away from each other. So you can see the only difference with the sign flip there. So let's go ahead and solve this. Nothing's different than we've already done. Okay, that's a small fib there. We do, because we have an inequality sign, have to pay attention to one additional rule. If we divide or multiply by a negative number, that equals to flip the sign. That's the only new piece that we have to add in from part 1. So let's go ahead and do this. This will be our negative solution to the insides of the absolute value, and this will be our positive solution for it. Again, just like we did before, so we're going to go ahead and write -1 minus 2x. That's my negative terms inside the absolute value. Again, it's already isolated, is less than 9. In this case, I'm going to write the word and. You know why? Because it's a less than. Here's my positive version of what's on the inside of the absolute value inequality, which is 2x is less than 9. We're just going to solve these. And when we're done, we're going to graph them. It's going to look like that. It's going to be an and, so there's going to be a barbell. Again, let's get rid of that negative. Are you ready? Are you ready? Remember, when we divide or multiply by a negative, we have to flip that sign. So now the sign's going to flip. So I'm going to go ahead and change my color, flip that sign so that you can recognize that the sign's flipped. I'm going to go back to blue and finish it off. So I'm left with 1 minus 2x, after those reduced to 1, is greater than -9. All right, so I'm going to subtract 1 from both sides because I need to, I'm going to save room here. Subtract 1 from both sides, leaving a -2x, and greater than -10 because a -1 and -9 make a -10. And now I'm going to go ahead and divide again, but I'm dividing by a negative, so I get a second flip in this scenario. That's okay. That happens. So I'm going to flip it back. Okay. So now that I got it flipped back, those reduce to 1, leaving x on the left, and -10 divided by 2 is -5. So there's the first part. Oh, that should be a negative there, sorry. That should be a +5. There it is. So 2 negatives make a positive, and this should be positive 5. So all my solutions are less than 5. Here's 5. It's an open circle because there's no equal sign underneath, and it says all my solutions are less than 5. So that's what I got so far. Let's do the other side. Subtract 1 to the other side. So I get negative 2x is less than 8. And I'm going to divide by negative 2. Again, watch your flip. I got to flip again. So I'll do it in black so you can see it flip here. So there's the flip, and so these reduce to 1. X is greater than negative 4. So all my solutions are greater than negative 4, no equal sign underneath, so it's an open circle, and I graph to the right. So you can see it made the barbell shape. Nothing's different. I do have to pay attention to this. It will happen from time to time. Okay, let's do the great or sum here. And do this one a little bit quicker. Again, let's do a negative and a positive version. Here's my negative, here's my positive. So negative 1 minus 2x is greater than 9. Or, this is an or, this one was an and, this is now an or because it's a great or. And then I'm going to write, no parentheses for this, 1 minus 2x is greater than 9. So I've got my 2, all I have to do is solve. Divide by negative 1 on both sides. This is my sign flipping right here. So I get 1 minus 2x, switch my sign, negative 9. Subtract 1 from both sides, so I get negative 2x is less than negative 10. And I'm going to divide by negative 2 on both sides. Again, watch your flip here. So I'm going to flip my sign. I get positive 5 on the right. Those turn into 1, so I get my solutions are greater than 5. So you can see this time I'm at 5, not colored in, and I'm going to the right. So you can see the difference there. Let's finish the last one. Subtract 1 to the other side. Negative 2x is greater than 8. Divide by negative 2. So I get x, flip my sign. Right, divide by a negative, flip my sign, x is less than negative 4. So my solution's at 4, not included, so it's open circle going left because it's less than. So that's the gist. There's 2 examples. You're pretty good after that. Let's at least tackle one more example on here. Try to keep this as short as possible at the same case. So let's grab, we'll stick with the blue here. So I'm going to take the blue. Here's one. Let's just name these. So let's just identify these types here. This is an absolute value. This is all isolated. That's what you have to do first. And my sign then is a greater. So this is an or, and it would look like this before I graphed it. I can just tell you that because it's a greater than symbol. This one over here is a less than symbol. So this is an and it's going to look like a barbell when I'm done and I've graphed it. That just gives you the gist of what that's useful for. Doesn't do anything for you in the solutions. You still treat it the same way you've done everything else. So we're going to do one more equation. You can check out 4 on your own. I'll leave it up here. But let's solve this one. It's a less than sign. So I know it's going to look like this over here. So let's go ahead and separate this into 2 different insides, one for the negative version, one for the positive. So I'm going to get negative n plus 1 is less than or equal to 7, and n plus 1 is less than or equal to 7. So there's my 2 inequalities that I'm going to solve now. Divide by negative 1, divide by negative 1. Again, flipping, check your flip. I'm going to get n plus 1 is equal or greater than or equal to 6. Subtract 1 to the other side, and I find out that n is greater than or equal to 5. Feel like I did something wrong there. I'm going to double check. That should be a division of a negative, so that's going to make that a negative 7, and when I subtract it over, it's actually going to make it a negative 8. All right, so that's a negative 7. I subtract 1, so this should be a negative 7 here. This should be a negative 8. Sorry about the mistake there. So there's my negative 8, right? And all the solutions are greater than, open side first, so I'm going to the right. Subtract 1 to the other side. N is less than or equal to 6. There's my 6. The solutions are less than. The small point comes first, so I'm shading to the left. All right, minus a little mistake there. I think you get the gist. The process is the same. You got to pay attention to 2 new things. 1, the division and multiplication of a negative equals flipping. That part you have to watch. You've seen that we flipped a lot in there. And then 2, you just need to make sure that you have the right solutions based off of the less than sign or a greater sign. Just make sure that it matches when you're done. It's more of a check than it is anything else. You don't need to mind it. You still do the same process. Okay, there's your notes for part 2. I'll see you in class for any questions.